work. If you would prefer to just watch, that's totally fine too. And I'll go ahead and get started. So welcome to CU Data Week. I recognize some names from other talks this week, so that's super exciting. My name is Grau. Most people call me Lala. And I am a research instructor at CEDA, or the Center for Innovative Design and Analysis. I've been with the university for 5 years this year, which is kind of crazy. Time flies when you're having fun. And yeah, I've been organizing CU Data Week. So check back with other lectures this week. We have a bunch coming up on how to use R, creating tables in R, creating figures in R, data management in R, etc. So make sure you don't miss those. We're also raffling off an iPad, a Garmin watch, and some wireless headphones. So before you leave today, make sure that you fill out the attendance, which I'm going to post a link for right now. Make sure you fill out the attendance for each class you attend. You get entered once into the raffle. So that's pretty good. Good chances of getting some cool prizes. Before I get started, does anybody have any questions for me? Nope. All right. Feel free to stop me at any time. I'm happy to answer any questions at any time. So in the basic statistics in SAS folder in the OneDrive that I shared the link for, you should see 3 files. One is a SAS data set and one is a SAS program. I'm going to be working inside SAS on my computer, but I know a lot of people use SAS on demand. So if you have any questions about using SAS on demand, feel free to ask me. I actually teach the 3-credit class, the SAS data management 3-credit class at the School of Public Health, entirely on SAS on demand. So feel free to ask me any questions that you might have. To get started, so I'm assuming you have some sort of background in SAS, but if you don't, that's totally fine. We can still get through today. Some SAS basics before we start. In SAS, wherever you're storing SAS data, it refers to those as libraries. So if you look over on the left-hand side of your SAS session, those are active libraries within your SAS session. And so there's a few, which I'm pointing to, that are kind of automatic SAS libraries. Most of the time, people like to work in the work library to create temporary files that then they later save into a user-defined library. But I personally like to work entirely or almost entirely in permanent libraries, which means there's an actual physical folder on my computer that I read data from or write data to. In this case, I'm just going to be working off of this OneDrive folder that you all have access to. So I need to tell SAS that this is the data set that I want to work with. So I'm going to create a library to that folder. Essentially, what I do is I copy the pathway, copy address as text to the folder, and then I have lib name, which is essentially telling SAS, hey SAS, I want to create a library. Then I name the library. Essentially, you want to give a nickname to each folder. The only rule here is, well, there's 2 rules. It has to be 8 or fewer characters, and it can't start with a number, and it doesn't have any symbols. So you can't do like question marks or anything like that. And then within quotations, you're just going to paste the pathway to that folder. And so when I run this, I'll go to my log and you can see that the libref was successfully assigned as follows. And then if I actually double click on the library that I just created, you can see this birth weight clean data set that I have inside that folder. So now that I've actually told SAS, hey SAS, please talk to this folder, now I can actually interact with the data that are living inside that folder. So the first thing I always like to do is to just look at the contents of my data to really understand what am I working with. Proc contents is essentially asking SAS, hey SAS, what are the variables in here? When was this data set created? How many observations does this data set have, etc.? Then we say data equals, and we point it to whatever data set we want to work with. And I've added this var num keyword here, which is essentially saying, I want to see the variables in the order that they are in my data, as opposed to in alphabetical order. So we can check here the results. We can see that the birth weight clean data set has 50,000 observations and 20 variables. And if we scroll down, these are the variables that are in there. Now, if you're less familiar with SAS, it's really important that you understand that there's really only two types of variables in SAS. There's numeric variables and there's character variables, and you don't get anything else. If you work with other softwares, you might have like factor variables and strings and whatever. In SAS, you have numeric and you have character, and that's it. Numeric variables are exactly what you think they will be. They're essentially just numbers. The only things that are allowed in there are numbers like decimals, and scientific notation, and that's it. Dates are technically numeric variables, and then you just format them to display as dates. But in SAS, a date is really the number of days from January 1st, 1960. And that's what is stored in SAS's memory. Then we have character variables. Character variables are kind of the anything goes variable. They can be super short, like 1 character long. They can be 200 characters long, and anything can be in there. It could be a symbol, it could be a number, it could be spaces, it could be letters, whatever it is. As long as it's a character variable, anything goes. So once we know what's in our data, we see that we have an ID, weight, race, marital status, sex, maternal smoking, number of cigarettes per day, maternal education level, mom height, mom weight, mom education, BMI categories, low birth weight, and then a bunch of indicators for race and ethnicity. So that's the data that we're working with. Now, whenever you get a new data set, it's always a good idea to start with descriptive statistics. It's like bad statistical practice for you to run any sort of inferential statistics before you look at descriptive statistics. So there are a bunch of different ways to get descriptive statistics in SAS, and really every single programmer that you talk to is going to have a different preference. Some people love doing everything in proc mean, some people love doing everything in proc freak, some people love doing everything in proc report. I am personally of the type that I like doing everything in proc tabulate because it handles character and numeric variables really well. And so you can treat variables as categories, or you can treat them as, a continuous variable that you want, like the mean and standard deviation, versus you could have a variable that's character, or not even character, but some sort of classification variable. You can also get like the N and % from that variable. So here I have two examples. The proc is called proc tabulate. We're always going to say data equals, and then we're referring to the birth weight data set by the libref, which is the nickname to the folder that we created. So it's in the DW folder, and the data set is called birth weight clean. Now I'm adding a class statement, which means that everything that SAS is going to do with this variable, it's going to be based on the categories of that variable. So in this case, I'm essentially stratifying by maternal smoking. Then in my var statement is going to be all of my continuous variables. So any variable that isn't really a category. Now you have to be really careful and intentional and know your data, because you could have a variable. If we actually open the data set, you can see that maternal smoking, for example, is a numeric variable. It's 0s and 1s, but it's not something that you would take the mean of. Like you wouldn't take the mean of a binary variable. So I know to put this variable in a class statement versus something like weight, which is actually a continuous variable. The numbers are not representative of categories. I would know to put this in a var statement and then this in a class statement. So I have that, my class and my var. And then I'm going to add a table statement, which is essentially telling SAS instructions on what I want the table to look like when I create this. So I'm going to run the code and actually point you toward what each little bit of code is doing. So I'm going to split my screen. I wish there was an easier way to split screen, but I haven't figured it out. If anybody knows, please let me know. All right, so here I have my code and then my table. So do you see that I have table and then weight and then a comma? Anytime that you have something before a comma, those are going to be rows of your table. Then after the comma, it's going to be columns of your table. So I want one row for my weight variable, and I want one column for each category of my maternal smoking variable. Now I'm asking for two different statistics here. I want the mean and the standard deviation. So essentially for each column of mom smoking, within it, I'm going to have two columns, the mean and standard deviation, which you can see here. Mom smoke, the non-smokers, I have mean, and then I have standard deviation. And then the smokers, I have the mean, and then I have the standard deviation. Now, I added a little bit of extra formatting things. And as you learn these procs, you kind of get used to how you like to see your data. I personally like to, at least initially, see up to 1 decimal point. And so I've added this asterisk F equals, which stands for format equals. And then I've added the comma 9.1 format. Formats are a whole lecture in my SAS class, but it's essentially you tell SAS instructions on how to display the variable without ever manipulating the variable itself. So the values of my variable are staying the same. I'm just displaying it differently. And then I have this no cell merge because sometimes Proctabulate merges cells really weird and I don't like it. So I just have that there as a preventative measure. All right. Now, what if we have two classification variables? So here I had one continuous variable stratified by one categorical variable. Now I have mom smoking and mom education level. Those are both categorical variables, and therefore I need to calculate some different statistics. So in this case, I want to look at the N and the percent. So let's run the code and look at the output. Now, again, before the comma is going to be the rows, and then after the comma is going to be the columns. So I want one row per level of the mom education level. And SAS knows not to average these, but instead of treat them like individual categories because both variables are in my class statement now. And then I have a column for each level of mom smoking, and then I have the N and then the column percent. So you want to be really intentional about what percent you calculate. So sometimes in a table you might want to calculate, let's say, a percent of your whole sample. Or sometimes you might want to calculate the percent of the row, and sometimes you might want to calculate the percent of the column. And so you want to be really intentional about what you're presenting, and you want to know that when you put it in a table. So in this case, for example, I'm calculating the percent for the column. So if you add up these numbers to each other, you should get 100. And if you add up these numbers to each other, you should get 100. You could also ask, for example, for a row percent. So instead, the row would add up to 100. So it would be essentially what percent of moms who have an education level of 0 smoke. So that's a different question than what percent of smokers have an education level of 0. Does everyone see the difference? So I'm going to take a little pause here, and I'm going to check the chat box for questions. Thank you, Carla, for sharing the link. And then, yes, Sarah, I'll speak slower. Sorry, I get really excited about statistics and then I speak very fast. But there will be a recording, so you can check back if I'm speaking too fast at any point. Any other questions before I keep going?
I did have one question. So
Sure.
in the table code right there, it says weight, comma, mom smoke. At the end of that, it shows asterisk F equals comma 9.1.
Mhm.
I think you said that the asterisk F equals function. Is that correct?
So this is essentially the F stands for format, which
Okay.
is in SAS, in the SAS world, you have the data and then you have how the data looks when you look at it. So I can actually give you a good example of a format. So for example, mom smoking, we have zeros and we have ones, right? But zeros and ones don't really mean anything. It's really a no and a yes. So you can actually format your data to display the zeros as no's and the ones as yeses, but the data itself is still zeros and ones. You'll just see no's and yeses. So that's what formats do. Let me call this mom smoke. And then we're going to do 0 equals no and 1 equals yes. So this is me creating a user-defined format.
Mhm.
And again, this could be like a whole class. But I can have a format statement for mom smoke. Oops, that is not what I wanted to do. And then essentially have the values display as no's and yeses.
Mhm. That's great. Thank you for that. And then my only other question was equals comma 9.1. Could you remind me what the 9.1 stands for?
So 9 is, so this is weird, and I know it's weird, but 9 is essentially the entire width of the variable. So however many numbers or decimals or whatever you want to have. And then the 0.1 is essentially how many decimals you're going to need. So I typically leave 9 in most of my formats unless I'm dealing with like billions. But then the thing that I really like to change is the point whatever. So for example, if I do 9.0, it's going to display no decimals.
Right.
And then if I do let's do 9.5, it's going to display 5 decimal points.
Gotcha. Thank you.
Yep, you're welcome. All right. Anna's asking about the no cell merge. So in this example, it's a little bit funny to see. So I'm going to run it without. Do you see how this top row, the cells get combined in this top level, where essentially there's this row and there's this row, but in the actual data, it's at one row, it merges them together. It's super silly. I don't know why SAS does that, but it annoys me to like literally the moon and back. And so I like to do the no cell merge so that it's just nice and clean. And if you export this, for example, like you could copy and paste it into Excel, then you don't have to unmerge the cells and move the data around. I don't believe in doing very many things manually, if ever. Other questions? These are great questions. Thank you all. All right. So now that we've like looked at the descriptive statistics, we can start thinking about running some actual inferential statistics. Now I'm going to be showing you a couple of different tests that are the most commonly seen tests. But feel free to stop me and ask me questions. But yeah, so let's ask scenario number 1. Is maternal smoking associated with low birth weight? So up here, we looked at mom education level. We want to look at low birth weight with mom smoking. So I'm going to change some things around to get some descriptives, and let's take a look. So we see that among non-smoker women, there's approximately 5% of non-smokers end up having a low birth weight baby versus moms who smoke, about 10% of them end up having a low birth weight baby. And so we want to test essentially, is this 4.9% different from this 10.1%? So we can run a proc freq. That stands for proc frequency. It's also another proc that you can use for descriptive statistics, very frequently used for descriptive statistics. And it's going to create this cross tabulation similar to what we've created here, but it's going to create that 2x2 table that epidemiologists love. So we have 0, 1 and 0, 1, and we see the cross tabulation of those variables. So that's what proc frequency stands for. Now we have data equals, same thing we've been seeing of how we refer to the data. Then we have this new statement called a table statement. And the table statement is essentially, hey, SAS, this is the variables that I want to look at. Because I want to cross tabulate these variables, I want to look at the level of low birth weight in the categories of maternal smoking. I'm going to do low birth weight asterisk mom smoke. This is essentially going to put them together in the same table. If I don't have the asterisks here, it's just going to give me the individual frequencies. Oh, I have to remove the chi-squared because then it's doing silly things that we don't need. So it's just going to give me the individual frequencies of those variables, which is not what we want in this case. It's good for descriptives, but it's not exactly what we're trying to get at. So I'm going to put the asterisk there, and then after my variable names, I'm going to do / chi-squared. So when I run this, got to rearrange my screen. We have this cross tabulation table, and SAS actually describes to you what all of these numbers are because there's a lot of numbers in here. So the first number is going to be the frequency. So if you look at the first number in each box, it's just the number of women. So 41,333 women were non-smoking women who did not have a low birth weight baby. Then 5,872 were moms who smoked who had a normal birth weight baby. Then 2,134 are non-smokers who had a low birth weight baby. And then 661 were smokers who had a low birth weight baby. Then we have percent. And this percent is out of the whole sample. So out of every single woman, out of all 50,000, what percent are in each cell? So 83% are in this cell, 11 or 12% are in this cell, 4% are in this one, and 1% are in this one. So it's the overall percent with 50,000 as the denominator. Then we have the row percent, which if you look horizontally, you'll see that 87.56 plus 12.44 equals 100. So the denominator in the row percent, or this third percent here, is using this as the denominator. The row total is the denominator. So 41,333 divided by 47,205. Same thing here, it's 76 plus 23. And then the last one is the column percent. So now the denominators are going to be these numbers. So 95% of moms who did not smoke had a normal birth weight baby versus 5% had a low birth weight baby. Any questions on this cross tabulation? None yet? All right. Then we asked SAS for this chi-squared test. And you're going to get a lot of stuff in here that is beyond the scope of this 1 hour lecture. You're really only interested in this statistic chi-squared, and you see the degrees of freedom, the value, and what most people look for is this p-value. So whenever in SAS you see prob, it's the p-value. So here the p-value is significant. So there is a significant difference in low birth weight rates among women who smoke versus women who did not smoke. Now, SAS sometimes will automatically give you the Fisher's exact test. Essentially, you want to use a Fisher's exact test when the expected count in each cell is less than 5. SAS will typically give you a warning when it's not appropriate to use a chi-square test. So if you have really small sample sizes, SAS will actually tell you, hey, these cells have cell sizes less than 5. So you might want to consider not using the chi-square test. It'll actually yell at you a little bit, which I personally appreciate. And then you can look at the Fisher's exact test p-value, which would be this one down here. This data set has 50,000 people, so we don't really have a small cell sizes problem. All right, any questions so far? Okay, so we've dealt with two categorical variables. I'm going to add a little bit of summary. Two categorical variables. Now, what happens if one variable is categorical and then one variable is continuous? So in this case, what if we wanted to know whether the birth weight of the infants differs between moms who smoked and moms who didn't smoke? So we're going to go back to our proctabulate up here, and I'm going to bring it down. And we're going to look at the descriptive statistics for weight. And I'm going to add my format because, well, we created it, so we might as well make our data look pretty. So let's run this. So the average weight of infants for moms who didn't smoke was about 3,400. I want to say this is grams. If one of you is a physician and I'm wrong, I'm sorry. And then among women who did smoke, the average weight was 3,160. So what if we wanted to test if these values differ from these values? Well, we can use the best and most frequently used prog-t-test to test that. So we're going to use prog-t-test. Data equals, we'll give the name of our data set. And then in our class statement, we're going to include the categorical variable. So in this case, it's maternal smoking. And then in our var statement, we're going to include the continuous variable, which in this case is weight. We'll go ahead and run that. Takes a little bit because the data set is pretty big. And we're going to get a ton of different output. So you'll notice the first thing is SAS automatically gives you some descriptive statistics. We have the sample size and mean weight for moms who didn't smoke and moms who did smoke. And then we have the difference between those two averages, assuming a pooled or Satterwhite, essentially equal or unequal variances. In this case, the means are the same, but the standard errors are different. That, again, is a little bit beyond the scope of this 1 hour lecture. You also get means and confidence limits if that's what you choose to report. Now, the table that you're truly interested in looking at is this one, which is essentially the p-values for the t-test, whether you're assuming equal variances or unequal variances. And again, that's kind of beyond the scope of tonight, but typically it will be one of these two. And SAS even tells you like the equality of variances test. So here the null hypothesis is that there is no differences in the variances, and then the alternative is that there is. And so here I would essentially just choose to use the unequal variances p-value. But that's like an educated decision that you make as a statistician, but you have both. The unequal is a little bit more conservative most of the time. Now we also have plots. A lot of SAS procs have automatic plots that it will give you, and you can actually request more plots than the defaults. But in this case of the t-test, I think that the plots that it gives you are really informative. Essentially, the t-test, you want to assume that you have approximately normally distributed data. Really, it's hard to like eyeball really when something's truly approximately normal versus not. But essentially what you're looking for is this bell curve kind of shape to your data and symmetry. If your data was really had a really long tail or just didn't look symmetrical, then you might want to consider doing a different test. In this case, it looks pretty symmetrical, so I'm not too worried. The QQ plot, we can see here that you essentially want most of the points to be on this line. And you can see that here it's deviating a little bit, but the sample size here is so big that we can kind of lean on the central limit theorem and say, we can say this is approximately normal. But again, say if this is your first introduction to statistics, you want to take more advanced statistics classes so you make an informed decision before you evaluate some of these things. But I'm teaching you how to code it in SAS. Any questions about the t-test? Now, I want to show you all something that I think is really valuable that I really didn't recognize the value of until I became a professional biostatistician. But so we have a lot of output here, and oftentimes new programmers, new biostatisticians will look at these results windows and literally like copy and paste p-values into their reports. And I am a big fan of every single number that I put into a report or a manuscript is coming straight out of SAS in a reproducible format, so that if I were to completely change my data, I would have a report that has all the numbers updated without me having to manually be like, oh, where did I pull this number out of? I can't remember, especially once you work on like 20, 30 projects a year like I do. It's really hard to remember what you did in the past. So you want to kind of set yourself up for success. So I'm going to show you a quick little trick. If you run, sorry, my dog is barking. If you run ODS trace on, and then you run the proc, whatever proc that you're running, and you check the log once it's done, we have to give it a minute because the data is big. If you look at the log when you're done, there's all of these output added things. If you notice from before, we didn't have any of these before. So essentially this output added is all of the tables in the results window have a name. So if I actually put this side by side with my log, let's move this over. And we go side by side. This first table is the statistics table. This second table is the confidence limits table. This third table is the t-test table. This fourth table is the equality table. Then we have this summary panel. And then we have the QQ plot. So do you see how there's like a one-to-one for each thing in my results window? There's essentially a SAS table that's working behind the scenes. So you can actually create data sets out of some of these SAS tables. How you do that is, I'm going to turn ODS trace off so it stops printing to the log as much. But we're going to use the output delivery system, which is ODS, output delivery system. And we're going to say ODS output, and let's say I wanted to extract the p-values from my t-test. I'm going to create a data set, copy and paste the name of the SAS table in its memory, and I'm going to create a data set called results 1, for example. So this is saying, hey, SAS, please use the output delivery system to create an output from the t-test table that's called results 1. So then if I rerun all of this together, it takes a second. And then I go over, this is going to be in the work library because I didn't put a live name on this. But now, do you see how I have a data set that essentially is this table? Now I can print this table into a PDF file or a rich text file and be able to save all of my results in a document that will automatically update if I automatically update my data. I usually in my projects have a data raw folder, which is like the data I receive from investigators, the data process folder, like once I've completed all the data management and I have like an analytic data set, And then I have a results folder where I save all of these little SAS data sets with all the results for my manuscripts. Any questions on that? All right, I'm gonna keep going if everyone's feeling okay. I know it's late. Trust me, I know it's late. My brain usually shuts off at 2 p.m., so I'm really pushing here. I'm a morning person. All right, so what happens if you couldn't assume normality? Like, let's say your data is super skewed and you don't see this beautiful bell curve. You see a really, really long tail. Your QQ plot is totally out of whack. Then you would want to use a Wilcoxon rank sum test, otherwise known as a Mann-Whitney U test, which is essentially a non-parametric version of a t-test. It's essentially saying, I'm not assuming that this is an approximately normal variable. It's going to look almost identical. We're going to have the same class statement and the same var statement, but we're using a different proc. It's called proc n-par one way. And so we're going to say proc n-par one way, data equals, and then we're going to do a Wilcoxon test. Here I'm using the B-weight data set from SAS Help. SAS has a bunch of practice data sets if you're ever like wanting to play around with data. It's a library that just exists in your SAS session right here. And all of these data sets are just available for you to play around with. I'm so sorry if you can hear my dog. It's like the time when everyone's walking their dog and she has to scare them all away. I might actually close the door. Give me 1 second. Okay, sorry, she's very loud. So yeah, we're gonna do the Wilcoxon here, and I'll go ahead and run that and we can look at the output together. So here we have the Wilcoxon score, otherwise known as the rank sums. And then here's the Wilcoxon two-sample test. There's different schools of thought about which p-value to use, right? You can see a lot of p-values here. There's here using the z-score, here is using a t approximation. A lot of the times these are going to be very similar, but again, that's a little bit beyond the scope of the class. I would be concerned if you saw like very different p-values here. There's probably something weird happening in your data. And then the Kruskal-Wallis test would be if you have kind of more categories than just two. But it also gives you this beautiful box plot so that you can visualize your data. If you had really skewed data, these box plots would not look like these. You would have some really long whiskers of your box plots, and your mean and median would be kind of far away from each other. This is kind of a good indicator to me that the t-test is appropriate because these look symmetrical, approximately symmetrical, and the means and medians. So in SAS, this line is the median, and then the little diamond is the mean. They're not too far away from each other, which means it's not very skewed. But yeah, n-par one way is your go-to proc for non-parametric continuous tests. Other questions? Otherwise, I'll just keep going. Okay, so what happens when you have paired data? And again, this is like a quick 1-hour seminar, but you really want to understand exactly what is in your data, right? Oftentimes we talk about correlated data. Like, do you have the same measure on the same person at 2 different time points? I personally work with the Anschutz Health and Wellness Center on a lot of weight loss studies. And oftentimes we're comparing like the weights at baseline to weights at 12 weeks or 24 months or whatever the length of the intervention was. And so as a statistician, I have learned to recognize when I have correlated data, or for example, paired data. So if we were to look at, for example, cars, we have a measure of the miles per gallon in the city and the miles per gallon of the highway on the same cars. So if we actually open up that data set, this is another sample data set from SAS Help. Highly encourage you to play around with these data sets. They're really fun. We essentially have one row per car and a bunch of different measures on the cars. And I'm personally interested if miles per gallon city is statistically different from miles per gallon highway. Now, because it's two measures on the same car, I want to make sure that I'm taking into account the fact that it's the same car in both measurements. So I do that by using a paired t-test. So here I have prog t-test, data equals, so this part is the same, but now do you see how I have this paired statement as opposed to just the class and var? In paired, we're going to put two continuous variables and we're going to put an asterisk between them, which says, I want to look at whether these are different, taking into account the fact that they're measured on the same car. So when we run this paired t-test, it takes a little bit. When we run this paired t-test, we're going to get some output. We have 28 cars. The average difference, it's going to take the miles per gallon city minus the miles per gallon highway. And essentially what we're doing here is we're testing if the difference is significantly different from 0. So it's going to calculate the difference between these and test, is it significantly different from 0? And we see if we look at this p-value table that the p-value is significant. So SAS is telling us, yes, there's a significant difference between city and highway. However, when you look at some of the automatic plots that SAS gives you, you might be raising your eyebrows and saying, I wonder what's going on here. So here you see that this little red line is kind of helping you visualize your data a little better. And the blue line is an approximately normal, or actually in this case, it's a normal distribution. And you can see that the red line of your data is deviating quite a bit from the blue line of a normal distribution, which raises a red flag. Hey, maybe I shouldn't be using a test that assumes normality. This graph, I think, is hard to interpret. This graph is showing you like the mean of each. So we have miles per gallon city and miles per gallon highway. And this little line here is essentially saying they're equal. So if all the lines were on the point, it would mean that there's really no difference. If all the points were on the line, sorry, I just misspoke. But here we see that all the points are a little bit off from that null line. And then here the QQ plot is for assessing normality, but in these data, it's kind of weird. But honestly, based off of just looking at this graph, you would want to be like, let me look at a non-parametric test. So how do you do a non-parametric pair t-test? Here, we're going to look again, is there a significant difference in miles per gallon city versus miles per gallon highway? And we're going to assume that you cannot assume normality. The distribution's funky, so we want to be a little careful. So we're going to do the Wilcoxon signed rank test. And I'm throwing a lot of different vocabulary at you. In order to do this non-parametric test, there isn't really a proc that you can easily do. I think the easiest way is to calculate the difference. So we're going to use a data step. In SAS, basically, a data step is used to manage data, and then procs are used for very specific functions, whether it's statistics, reporting, whatever. So I'm going to create a new data set called analysis from the SAS Help Cars data set, and I'm going to create a new variable called diff. That's the difference between miles per gallon city and miles per gallon highway. Then I'm going to run proc univariate, which is a really robust proc that gives you a whole bunch of different information, including the Wilcoxon signed rank test p-value. So here I'm going to do data equals analysis because it's this new data set that I'm using. And then I'm going to have a var statement for the diff variable, which is basically, hey, SAS, I want to look specifically at this diff variable. So when I run these, There's a lot of stuff that can come out of proc univariate. I'm just warning you. But we're going to look at these tests for location. And so these tests for location are really going to look at a bunch of different things. We have the t-test, which we ran before, but we also have this signed rank test, and that's what we want to look at. This is the Wilcoxon signed rank test, which is essentially the non-parametric version of the pair t-test. And so this one is significant, which tells us that yes, there is a significant difference between miles per gallon city and miles per gallon highway, taking into account that those variables were measured on the same cars. Questions? If you're unfamiliar with some of these data steps, I highly encourage you to follow us, follow CETA on either LinkedIn or Twitter. And once we upload all of the Data Week talks, you can look at the YouTube video of the lecture that was today at noon, which was SAS data management. Or you can take my class in the fall and hang out with me for 4 months while I nerd out on how fun SAS is. All right, I don't see any questions, so I'm going to keep going. We're almost to the finish line. Now, you know, every intro statistics class is going to teach you to do a linear regression. It's kind of like the pair t-test or t-test and linear regression are the things that like intro biostatisticians learn. So I took a class a few years ago, and the professor used to say, you cannot run a regression without looking at a plot. If you don't look at a plot before you do a regression, it's statistical malpractice. And I find that hilarious, but I live by it. So let's say if we wanted to see if there's a significant association between height and weight among school-age children. We have here another SAS help data set from, it's the class data set. It's essentially one observation per student. What if we wanted to see if there's an association between height and weight? I'm going to use this proc SG plot, which is one of the, well, it is the most used graphing proc of SAS. I will say personally, I think it takes a lot of code to make SAS graphs beautiful. So if you're familiar with other statistical languages like R, stick to making figures in R. That's just my advice. It takes a lot of code to make a SAS figure beautiful. But here we have a scatter statement. There is a bunch of different options for proc SG plot. You can make horizontal bar charts, vertical bar charts, scatter plots. You can graph a linear regression line. You can graph a low S curve. You can do a bunch of different things. In this case, I just want a simple scatter plot between height and weight. So if we look at the results, we have height on the x-axis, weight on the y-axis, and we have 1 point per student. You can see that this isn't very pretty. Just as a quick intro, you can change things about your figures using attributes. There's different attributes. There's marker attributes, line attributes, fill attributes, confidence limits attributes. Essentially, every aspect of a figure has a corresponding attribute. And so I'll show you towards the end of class, like how to check the SAS documentation, and you can find which attributes correspond to what part of your figure so that you can manipulate them. In this case, the markers are literally each point. And so I want to change them. I want to make the symbol be circle filled, and I want the color to be purple. Why not? So when I do that, I can change my figure a little bit to make it a little bit bigger or prettier, I mean. So here we see that there is some linearity. We can see that like as height is increasing, so is weight, which is encouraging. Another thing we want to look at is the distribution of these variables. Like, is one of them really skewed or not? This data set only has a few data points. It's not 50,000. So we're not going to see perfect symmetry because it's a smaller data set. I would be concerned if, for example, we graphed this and it was like wee or like wee, like where you have very extreme values. But right now, nothing is like super standing out to me too much. So I can run procreg, which is the linear regression proc. Now, one important note about procreg is there's a handful of procs in SAS that require a quit. Most of the time, run our step boundary. You put run after a data step, you put run after a proc. But there's some procs that require you to quit. Otherwise, SAS will be running a whole bunch of stuff in the background of its memory until you tell it to stop. So it's more efficient and better for your computer not to crash if you make sure that you put a quit after procreg. So we're going to do model, and then we're going to do y equals x. So my variable weight is my outcome, and x is my predictor. And so I'm going to look at the relationship between height and weight in this case. I know this is a silly example, but I wanted something kind of really obvious so that you could take a look. So there's a lot of output for procreg, as you can see. Up here, you're going to see the number of observations read and the number of observations used. Be really diligent about checking this whenever you run anything ever in statistics. Make sure you know when you're losing people or records and why. I would be really concerned if I have a data set of 19 students and my model's only using 10 of them. I'd be like, okay, something weird is going on. Maybe I have missing data. Maybe I shouldn't be running this model. So always check number of observations read and number of observations used. Then here we have our ANOVA table looking at the analysis of variance. Depending on where you are in your statistical journey, you might be interested in the mean square error and the mean square of the model, or this F-test. You might not be at this stage. I'm not going to go too much into it. What I go to very quickly is the parameter estimates. It's essentially, if you've taken an intro stats class, it's the beta coefficients for the regression. So we have the beta of the intercept, which is negative 143, and we have the beta for height. So for every 1 unit increase in height, there's a 3.9 unit increase in weight. And then we can see that that is significant, which means that there's a significant relationship between height and weight. Here are the fit diagnostics. I won't go too much into this, except that I highly encourage you to take an intro stats class to look at model fit assumptions for a linear regression. You'd essentially learn how to assess what these graphs are telling you. You want to look at normality, heteroscedasticity. You want to look that the residuals are approximately normally distributed, things like that. But that's a little bit beyond what I can teach you in the next 7 minutes. And then at the very end, you have a fit plot, which is a little bit of a good way to visualize the relationships that you're modeling. Now, I mentioned when we were looking at the t-test using ODS reporting to create reports with your statistics. And I think if there's one thing you take away from tonight is really always make sure that you can reproduce your results, and that if, tomorrow you were to be sick and you can't go to work and you have a paper due, that someone else can reproduce your results and take over for you. So let's pretend that this linear regression is the thing that's going into my manuscript, and I need to make sure that I can reproduce that. I can actually create a report with this output. So SAS has the output delivery system, which can also be used to create PDF or RTF files, Excel files, HTML files, a bunch of stuff. I'm personally a fan of rich text files because they work really well with Word. You actually open them in Word. So we're going to say ODS RTF file equals, and then we're going to write the pathway of the file that we want to create. I'm actually not going to create it in this folder because then all of you will have a random document in your folder, but That's not gonna work. Let's do it on my desktop. So why isn't it getting the whole pathway? I don't think that's gonna work. Let's put it in documents. I'm just gonna create a folder in here called temp. So in this temp folder, I'm going to, there we go. Sometimes if it doesn't have the C, it doesn't work. And so the pathway to the folder where I'm saving my report and then what I'm calling my report. So I'm going to call it Lala example. And then I'm going to put this macro variable, which is called sysdate9. This is macro variables are essentially SAS's way of copying and pasting things into a report really quickly. There's some macro variables that are automatic in SAS. So for example, this sysdate one is system date. And so whenever you put that in, SAS is automatically going to plug in the current date of your SAS session. So if I rerun this code many, many times, I'll have one report for each time, each date that I ran the report. And so Lala example, sysdate9, and then .rtf. RTF stands for rich text file. And then ODS RTF close after the proc that I'm running. Now, I'm going to show you what this looks like just straight out of SAS without adding any cute things to make it pretty. So you see Lala example and SAS automatically plugged in 31 January 2023. If I double click that, I can open my Word document. And this is what it's going to look like without me modifying anything. It's just putting the SAS results into a rich text file. You can actually manipulate this quite a bit to be pretty, and I could teach a whole class on pretty reports. A simple thing is to change the style. I personally am a fan of journal style because the tables, not the figures, but the tables are formatted really well, usually with journal style, so that I can copy and paste them into manuscripts. So here you can see that the output changed a little bit to be prettier. You can also add titles, for example. So here I'm going to add a title, SAS example, and it will print that into my report. Give it a second. It will print that into my report to make it kind of a little bit more clear. So everyone, that is all we have time for tonight. Let me get the link. I already gave you the link for the attendance. Make sure you fill in the attendance so that you can be entered into the raffle. And I'm happy to stick around for a few minutes if anybody has any questions. Other than that, thank you so much for joining me tonight. I'm sorry if I talk very fast. I just love statistics. But feel free to email me. I'm going to put my email in the chat box if you have any questions or want to connect after this. Thanks, everybody.